Yeah. So we have just talked about what we call structure process transformation, which is going to help us in order to start what we call taking care of converting unstructured to structured. In order to get there, we have used log file as input with three rows in it in order to convert unstructured to structured. We have done that, right? And we have also extended that with what we call adding three more rows in it to see the effect of that, right? So that's it. And we have seen that result in the target, right? Then remember, the main point when it comes to this particular structure process transformation is that it follows clear architecture, which in turn would make use of AI with ML predictive measures or predictive analysis techniques. As a result, it knows like how to build a model for a given input data. So model in turn would be translated to what? So relational data. It could be expressed based on XML or JSON or some other form. Yeah. But ultimately, unstructured form would be converted to structured form. That's the first part. So here we focus on what? Structure conversion. Yeah. Because play intention itself is uh, a structure part, right? So once you're done with that, then we need to know how to refer this particular what structure in order to perform this particular conversion from structure to structure, right? For that, what we did was we built a mapping where we referred this particular log file as input, and that will be mapped to the structure parser transformation, which in turn would take the responsibility of converting this unstructured to structured. And as a result, we could able to see that in the target. Yeah, I think we have seen that, right? That's a simple way to understand like how this structured transformation would work, right? Now let us try to understand what we call one more transformation, which we call normalizer. And after that, we would also talk about sorter algorithm because we talked about how we could able to arrange the data either in ascending or in descending order. But we did not talk about how the algorithm is going to work when it comes to sorting, right? So let us try understanding this, right? Yeah. So normalizer transformation, it has been designed to take care of converting columns to rows. Yeah. Or we can also say that we are going to perform pivoting. Pivoting means it is like what 180 degrees rotation or 360 degrees rotation. Yeah. Columns to rows, it does, right? So now let us try to understand how it works or where do we use it. Yeah. So remember, if you look at what you call any organization, right, where we can see n number of employees and each employee is going to play their own role. Yeah. So you will have, let us say, team member, then team lead, then project lead, then project manager, then senior project manager, associate vice president, VP, whatever. You'll have what clear what we call hierarchy defined over here. Now the question, let us say we need to understand the number of reportees under AVP. So how do you get it done? Yeah. So that's going to be the question mark, which means can we obtain the aggregative measures at any level in the hierarchy? Answer is yes. If yes, how do you do it? By using what? Normalizer transformation. Yeah. So that's where normalizer transformation will be used for. Clear, right? So that's it. Now the question, can we apply this particular normalizer for linear data? Answer is what? Yes, because anyway, as part of hierarchy, if you have one level, right, then we can say, or zero level, we can say it's going to be the linear data, which means linear data anyway is a subset of hierarchical data. Yeah. So that is why one can take care of this particular what normalizing or converting columns to rows. Yeah. So that's it, guys. Like how normalization would work. Now, when it comes to the usage, right? Yeah. So we just have to take care, like how many columns that need to be converted. Yeah. So, for example, if you want to convert example C1, C2, C3. Now, if you want to convert two column data to what? Rows. To do that, we use what? Occurs equal to 2, which means we are going to specify column 1, column 2, or column 1, column 3, whatever occurs, which means if we have data like this 1, 1, 2, 3, 4, 5, 6. In this case, if we say occurs 2 with columns, let's say with columns C1, we specify this C1, C2, then columns will be converted to rows, right? First row, second occurrence, 2. Second row, first occurrence, second row, second occurrence. So this is how columns data would be converted to rows. That's it. This is a simple way to understand how normalizer is going to work. Fine. So especially when it comes to reality, we've got mainframe system, right? Where you will have data that can be represented in what? Hierarchical or linear form. Yeah. In that case also, we can think of using this particular normalizer. Not only that, wherever you want to perform aggregator or aggregation operations, then we can convert columns to rows and then apply either count or any other aggregation operation. In such cases, we can think of using normalizer transformation. Yeah. So now, so we just have to specify occurs and what would be part of occurs, this means columns. So that also need to be specified. Yeah. So that's it, guys, like how normalizer is going to work. Yeah. So let us try doing it practically. After that, we will get into the next step. Yeah. What happened? Okay. Yeah. So we'll be using simple flat file as input. Yeah. Now let us try to configure this. So we got three columns, right? Now, normalizer. Remember, you'll have two predefined output ports. One to look at sequence IDs for every row, like 1, 2, 3, 4, 5, whatever. Other GCID, which we call occurrence value. Let's say we specified two occurrence, right? First record 1, second record 2. That's where GCID will be used for, just to identify occurs, nothing else. Yeah. Now we can create a new field, or we can also select a creation of new field from existing fields. Let us start with the new field part. Yeah, I'll just put here, let's say pivot. Yeah. See here occurs by default 1, which means only one column. There won't be any difference if we do this. Let us do this first, then we'll go with the changing the occurrence so that you will see the effect of this particular occurs. Yeah. Mapping. Yeah. So field mapping, there's only one occurs, so it's not applicable. Yeah. Yeah. Now let's try to configure target. Yeah. Okay. There's error here, right? You can see what is that error. At least one mapping field that is missing, right? That's because we did not add target, right? Yeah. Can you see here? We can just get it mapped. Now it will be valid. So you'll get only C1 column data because that's what we are trying to pivot. Anyway, it's not a pivot, actually linear data, right? We are not pivoting really because we are just testing. Can we use this normalizer even without pivoting? Answer is yes. So this is as good as like a straight through mapping. Yeah, let us refresh this. We got all 5 rows. Let's say that. Yeah, can you see here? Only one column, right? 14711. So whatever we have the source, same thing we have to turn it. This is the first example, yeah, where we are not really pivoting it. Now let us try to apply occurs. So here let's say occurs 2. Now we can see here, GCID, GK. GK means generate key. GCID means generated column ID or global common identifier. So which is this is for occurrence, this is for sequence ID, and this is for actual data for 2 columns. Yeah. So that's it. Yeah. Now we need to map it. Can you see here pivot 1 and 2? So what has to be converted? That's what we need to get it mapped here. Let's say C1, C2. Yeah. Even you can also map C1, C3, C2, C3, whatever. Whatever need to be pivoted, we just have to get it mapped over here. Yeah. That's all. And run it. Yeah. Can I say 12 rows? Because occurs 2, right? 2 into whatever occurs specified. Yeah. Let us see that result. Yeah. S- See here, yeah. Let me copy source data so that you will understand like how this pivoting has been taken place. Yeah. So this is the data. This is the result. First one, right? One is there. And second, see here, two should come in the next row. See, it has come. Oh, right. Similarly, second row, four started here. Second row, second column data, five. Likewise, you will see what total how many? Six rows. Six into two, 12 rows. That's what you can see here. That's it. Like how we could able to see the result here, right? Now, let's talk about system columns. GK, which is generate key, which is equivalent with surrogate key or unique ID or sequence ID. So you can see because once a pivot, right, we need to identify every row in unique way. To do that, we use what? Generate key. So you can see the values here 2, 3, 4, 5, 6, 7, 8 till 12. Fine. Now, this is generate column identifier, or we can also say that global common identifier. So based on the occurs, this value would differ. First row, first occurrence, value 1. Second row, second occurrence, second row, second column, which is going to be the second occurrence value. So global column identifier, column, which column? First column or second column? This is a second column. This is a first column. That's it. So likewise, it will be repeated for all the rows. So I hope you all could able to understand, right? Yes or no?
Yes, Nasiba. Yep.
Oh, perfect. So that's it. Now let us try to modify, see whether same concept is going to work if you want to deal with what more than two columns. Yeah. We just have to change what occurs. Let's say 3. That's the first change should do. Next, we'll map. See, pivot 3 has come in here. We can also see here unmap if it is mapped. Here, this is mapped already. You want to take out, we can unmap. Now, let's say we map it. Yeah. C1, C2, C3. Now we should get 3 into 6. 6 input rows, 3 pivoting, which occurs, right? 18 rows should come. Yeah. And we have used, anyway, all mapped. You can see all. And plus, If you don't want it, you can just clear map. See, nothing got mapped. Yeah. So if you want to map it again, so you can do that one by one. And that's the one thing. And second, see here, while doing map automatically, based on the field names, it will get mapped. Because field name, there is no match here, right? They won't get mapped. That's why in this case, we have to map it manually. Yeah. And yes, that I think we talked about it. Yeah, so let's refresh this. So we got 18 rows. This is what we expected, right? 6 into 3. Yeah. Now we can see. See, occurs here 3 now. 1, 2, and 3. Yeah. And this is for second row conversion. This is third row conversion, and so on. So this way we could able to perform normalization. Oh, sorry, normalizing, which is pivoting, we can say. So that's it about this transformation. Yeah. Now let us talk about this sorter algorithm. Yeah. So sorter will be used to arrange data either in ascending or descending. We all know that. Yeah. So based on what? One or more keys. Yeah. So now how it works. See, this is, as I said earlier, This is one of the expensive transformation. Why? Let us talk about it. Yeah. So, as we all know that this IICS follows what? Multi-threading architecture, right? So, which means there is going to be one process with n number of threads in it. So, there is going to be one to n correspondence between a process and threads. Fine. Which means when you run any mapping, right, there is going to be one process. Under that, you will have n number of threads. Example, in the last example, right, source one thread and normalizer second thread and third target one thread, right? Apart from that, you'll also have some extra threads like session thread and pre-session thread, post-session thread, mapping thread. These are the extra threads that you will have it, plus reader thread and writer thread. Yeah, that's it. So I think you all will be knowing like how DTM architecture is going to work. So data transformation manager, right, in Power Center. This is exactly similar to that, which means whenever we execute any mapping or workflow task, right, this flow of operations will be same, which means one process with n number of threads, and this thread count would be varied based on number of readers, number of writers, number of transformations that we have. Remember that. Yeah. Now, in this case, we have got this many number of threads like source, target, and other threads. This is going to be the count of total threads that are required in order to process this particular mapping, right? Anyway, because it follows DTM architecture, so same concept that we have in Power Center in on-prem, right? Now, let us talk about from the starter context. Do we have a similar process that we follow for sorter? Answer is no. Because why? The reason is sorter requires more than one thread. Now the question, what are those threads? So to answer that, we need to get into algorithm. When you try to sort the data, what it does, let's say we are going to sort 30 rows. Yeah. Yeah. And then at any given point in time, sorter would process all the rows or subset of rows. Based on what? Based on buff size or buffer size that we have. Let us say buffer can fit up to what? 10 rows. Yeah. So then sorter would take first 10 rows, then it is going to perform sorting, and result of that will be sent to intermediate thread, which is writer thread, using which it is going to write what we call 10 records which are sorted. Yeah. Let's say we call it as scratch 1. The same process will be repeated for rest of the 20 rows, 10 and 10, right? So three things. So there'll be three files over here. So which means it is going to perform partial sort and place result of this particular partial sort onto intermediate storage media. We call it as what? scratch disk. Yeah. So now what next? Next step is what? It is not a final thing, right? So we need to start making use of this all the scratch files as input. Scratch 1 plus scratch 2 plus scratch 3. It is going to read. Who is going to do that? So that is where non-final merge, or we can say final merge. Yeah. What it does, it is going to pull the data from all the intermediate sorted files. Then it is going to perform complete sort. That is a partial sort, right? Whatever is done here, it is a partial sort. Then it is going to perform complete sort, and result of that will be returned to what? By using writer thread to appropriate downstream transformation. Yeah, that's what happens. Yeah, for example, source, sorter, then aggregator. Let's take this. In this case, output of this particular sorter that will be taken as input to the aggregator. That's what will take place. That's the meaning of downstream transformation. So these are the simple steps that would be taken place as part of this sorted algorithm. Now let us try to count the number of threads that we have over here. First, sorter we have to sort partial sorted data. Second, we have got writer to write data to intermediate storage media, which is a disk over here. And next, we've got a final merge. So to take care of partially sorted data and combine and perform complete sort. And finally, there's one more thing here, complete sort. Yeah. So these are the number of threads. Yeah. So that's there are four threads here. Remember here. So which means we need four threads in order to handle sorting operation. Which means if you have four threads, now the question there is going to be spawn, which means we have to create each thread, right? So there is going to be spawn overhead. Then once you create, no, we need to make them to interact with each other, right? To do that, we need to establish the communication between what one thread to other thread. Yeah. So there is going to be what we call connection overhead. Yeah. So second overhead, right? And then the next is what you will have transfer overhead, because if you have multiple threads, no, there is going to be data transfer that should take place from one thread to another thread, which would lead to what? Transfer overhead. Yeah. So, because of these reasons, sorted transformation would take longer time to get it finished. Remember that. Yeah, that's one thing. Now, the question, another one, to extend this particular algorithm, let us say there is a what we call limit with respect to generation of number of partially sorted files. For example, let's say we have got only two files as a limit to dump them onto a disk. In such cases, what need to be done? We need to perform what I call again non-final merge. Remember, which there's one more thread comes in where we take only two files as input, then create again intermediate merge file, then again merge two files with another file, then perform final merge. So depending upon the limit that we have with respect to number of files, then you will have what? one more thread. But this is least occurring scenario. But in case if we hit that particular limit, then this particular thread would come in, or else it is not required. So in this case, again, one more extra overhead come in here, adding a new thread and building a linkage and start getting it processed. So which is a transfer overhead. All of them would lead to what? Uh, Performance hiccup. So that is where, that is why before we use sorter transformation, we should make sure that do we need it or not? If yes, use it. If not, if not needed, right, it's better not to choose it because I think we understood the kind of operations that it would undergo, right? Yes or no? Yeah. This is an algorithm that it follows, but we have got different bookish based algorithms. Like we have quick sort, bubble sort, linear sort, heap sort, whatever, right? It doesn't follow those algorithms. It follows its own algorithm. Yeah. And when it comes to this is an inbuilt algorithm built by Informatica. But in case if you want to use topmost algorithm that we have, right, then there is a sync sort, which is a third-party sorting algorithm. If you want, we can also get it integrated. Or let us say, if you want to make use of OS specific algorithm, for example, if you take the Sun Solaris, right? So Sun Solaris has got good sort command line utility, which is a bit faster than Informatica sort. Yeah. So, so which means depending upon platform, right, we can also use corresponding sort utility, which will take care of what you call arranging the data ascending or descending order. So which means depending upon the platform, yeah, we can choose it. But mostly, or more, I would say more than 99% of the cases, we would be using Informatica sort. Yeah, because it's ease of use, and then and we can. It would also make sure that it would use inbuilt parallelism techniques like pipelining and partitioning. Yeah. That's about what sort algorithm, guys. Any questions on this from anybody?
I'm good. Yes.
Yeah, I think that's all about sorting stuff and normalizer. Yeah. So there are no questions, and we'll stop here. We'll continue from it tomorrow. We'll see tomorrow which one maplet is there. So we've got a maplet, we got a SQL, and there are simple ones. We'll talk about it. Yeah, we'll talk about it. After that, oh, Java is also there. Yeah, three. Then we'll get into tasks. So task flows and tasks also we'll talk about. These are very simple things. Yeah. But anyway, we'll see that tomorrow. Fine.
Sure, Asim.
Yeah. Thank you
Okay.
and
Thank you.
bye.
Thank you. Bye.